So this is a view of the top cover with the speaker. The speaker's connected by a little connector which I can undo, and we'll give you a bit of a look inside. So this is a view at the bottom. We have here 3 RF preamps, 80, 40 and 20, and the logic from the Arduino turns on one of those preamps. Preamps contain 3 tuned circuits, and they are AGC controlled. They use BF904s, and we can raise considerable amount of gain, and the noise figure is very good on that chip, on that transistor, and the intermod distortion products are quite low. It's designed for car radios and to work in strong fields. So the RF preamps feed this mixer. This particular mixer is a H mixer. Contains 2 very small FET switches, and they are driven by the VFO through this device here, which is an amplifier, small differential amplifier, logic differential amplifier. The output of the front end mixer feeds the noise blanker. That's the noise blanker there, tucked away on this side of the case. It just fits in nicely. Bit of a tight squeeze, but there it is there. Just above it is some bandpass filters used on transmit out of the transmit mixer. We'll come back to that in a minute. On this side of the case we also have the Arduino Mega programming port, the USB port, and some external power when I'm programming it without turning the rig on. It's just available through the side. Just take the side panel off and we can program that device up. The output of the noise blanker feeds these 3 crystal filters, one for upper sideband, lower sideband and AM, selected by relays driven from the Arduino. That means that the BFO frequency is basically somewhere around 9 megs for all 3 modes. The same crystal filters used on transmit. There's some transmit functions here. Transmit voltage sets the gain, fixed gain of this section of the circuitry, and the filters are driven by some BF904s, both input and output, to match the impedances of the filters and also to supply a certain level of automatic gain control. The filters feed the IF amplifier, which is down here. It's an AD603. It's a surface mount one mounted on an adapter. Has tuned input and tuned output, and is AGC controlled. The output of the IF amplifier feeds a balanced demodulator, and that's just sitting in here. There we go, or product detector. That's another name for it. And over here we have the BFOs. There's actually 2 crystals, one for upper sideband and one for lower sideband, because their frequencies are very slightly different. And they're inside this shielded box down there. And one of the crystals is switched on for AM transmit. On receive, there's the BFO, of course, is off. This is the AGC board down here, which contains a couple of chips, a couple of op amps, and a couple of RF amplifiers or IF amplifiers that amplify the 9 meg signal prior to being rectified and producing an AGC voltage. So that's just tucked in there next to the IF amplifier. And the IF amplifier feeds an audio amplifier, a speaker amplifier, which uses a TDA 2002 8-watt chip. Sit there down there. And there are a number of connectors on that board for headphone, internal speaker, external speaker, and a small 1 transistor preamplifier to give us a bit of boost. Transmit functions, we have down here a microphone amplifier, which is a SSM2167 chip on a little module you can purchase, and it just plugs in. I've made it so it plugs into the circuit board There's a two-tone generator there consisting of a couple of transistors and some adjustments, and that microphone amplifier chip also contains a compressor and AGC system. So all up, it's just one chip does pretty well all of the transmit microphone processing. The microphone itself also has an onboard amplifier, raising a few dB gain and matching. The output of the microphone amp feeds this balanced modulator, which is a 1496 down there. It has adjustments for carrier null and also adjustments for AM modulation carrier level. So you can, this particular relay switches in additional resistors to unbalance the chip and produce some carrier output, which is then modulated by the audio to produce an AM signal. It's just tucked in there on this side of the case. All of the controls and everything are fairly easy to get to in this rig. That's why it's got the apron frame construction. Here you see the back of the TFT meter with all its little connectors. I'll put the connectors going to TFT meter on the back so I can connect and disconnect them as I need to see what goes on. Once the balanced modulator produces a 9 meg double sideband signal, it's passed through the crystal filters, which you see up here on transmit, and the output of the crystal filter is now a single sideband signal. That single sideband signal is on 9 megs, so it's fed into this SBL1 mixer. The VFO and the output of the crystal filters mix in this mixer to produce a signal on 80, 40 or 20. And that mixer and its output now feeds a bandpass filter, which I'll show you. The output of the transmit mixer on one of the three ham bands is now passed through these bandpass filters to remove the unwanted products. These bandpass filters each have a trim pot on the input, and that allows me to set the output level of the transmitter to be the same for all three bands, so that the microphone control and the drive controls sit at the same spot. The actual output from the mixer is different on each band. However, these trim pots allow me to equalize that output. Now, the output of the bandpass filters pass through an AD603 amplifier, which is just here tucked on the inside of the circuit board. The AD603 amplifier drives the 10 watt stage, and its main use is to act as an ALC control device. You don't need a lot of gain at this point in the transmit stage, but the AD603 has quite a large range of gain control, around 40 dB. So I take the signal from the a bridge, a Stockton bridge in the output. I take forward power and reverse power, feed it to a SWR and ALC control board, which I'll show in a minute. The voltages out of that board then come into then feed this AD603 gain control, so the gain goes up and down depending. If there's an SWR problem, the control signal pulls the gain back rather rapidly. If it's an ALC function, it just limits the power to whatever I've set it to, so it can't go over, say, 100 watts or 80 watts or some figure. So that's the AD603. There is a preset control here, which I can adjust from when the lid's on, so I can do a fine trim. Now I'll show you the ALC control circuit. So the output of a Stockton bridge feeds this ALC control, which is actually an LM3900 chip, which puts out a voltage depending on the level of the forward power and the reflected power. We have a trim pot here for adjusting the level of SWR, which will start to cause the power to be pulled back, and we have a control here which is used for adjusting the ALC point. Down here we have a bias trim pot which sets the resting voltage going to the AD603. So that's the ALC and SWR control. It's actually fed from a Stockton bridge, which is actually tucked in down here. It's a bit hard to see actually. Anyway, it's down there somewhere. There's the actual bridge coil, the little transformer. There's two of them. There they go, and they feed a pair of VK3AQZ detector chips, and they produce the voltages going to the ALC and SWR control, and also some voltages going to the TFT meter for forward power and reflected power. The ALC and SWR bridge are in the final part of the circuitry. The AD603 feeds the 10 watt stage made of the RD16. The 10 watts is actually padded back to 5 watts, and the 5 watts drives the MRF454 RF power amplifier, 100 watt RF power amplifier. So the 10 watt amplifier and the 100 watt amplifier on the back panel outside of the case keeps the RF away from the sensitive circuits, the low pass filter, the bias circuit for the PA, and then the various couple of connectors right at the back. So that's where the high power stages are fitted. So here's a view of the back of the VFO. The VFO contains an Arduino Mega which drives an SI5351 clock chip. The back of the VFO box contains a connector for measuring frequencies, a buffered connector, and down here we have a receive and transmit VFO output connectors. Over here we have a circuit board containing a number of relays. I think there's about 8 relays there, and they're the ones that select that switch on the various band devices, such as the preamps and the filters, and also the mode, such as the crystal filters and the BFO. Over here we have the TFT display, the rear of the TFT display. You'll notice there's a lot of connectors on the back of these two boards, or two units, and that's how it makes it a bit easier for me to get in and out of the device, unplugging leads, etc. Over here we have a number of strips. These are power supply strips. They get fed from the main power supply, which is tucked in here behind the back panel. There's also a fan there, which is a bit hard to see, but I've put a bit of light in there. There's the fan, and these strips, for example, this strip we're looking at now is for 10 volts receive transmit, and then there's a few others scattered around the case. That one is for 10 volt transmit, and underneath here, a bit hard to see, we have 10 volt transmit as well, 12 volt transmit and 10 volt receive. Over here we have 12 volt transmit, which is feeds the fan and other things like that. So they're just pieces of Vera board or circuit boards with tracks with these polarized KF connectors on them. Just makes it easy to distribute the power. And then I just use pre-crimped leads and pre-crimped connectors to connect up the various modules. Some of the modules require maybe ferrite beads and things like that on them, but generally it all seems to work quite well.